Hey there! Welcome to my channel. Today we are going to talk about Earth's biggest plate. So let's get started. If you've ever played Tetris before, you know that all of the pieces can fit together perfectly despite being made up of different shapes. And just like those puzzle pieces, the Earth's crust is broken into chunks called tectonic plates that move around the planet's surface. These plates vary greatly in size, but scientists have identified one plate that is the largest of them all. This supersized chunk of rock stretches from the ocean floor under the southeastern United States all the way across the Atlantic Ocean to Western Europe. It is so big that if it were its own country, it would be the 12th largest in the world. That's bigger than Saudi Arabia or Mexico. Now, while it may seem like the Earth's biggest plate should be the most stable and secure piece of land on the planet, this isn't actually the case. The North American plate is prone to sudden and sometimes violent movements that can cause earthquakes, tsunamis, and volcanic eruptions. So, what is causing these chaotic events? What makes this giant plate so unstable? And could an even bigger disaster strike at any moment? Stick around until the end of this video because by then we'll have the answers to those questions and many more. So, where exactly is this massive plate located? As its name suggests, the North American plate includes the landmass of North America as well as the nearby parts of the Atlantic Ocean floor. In fact, it covers an area of about 17 million square miles, which is nearly one-third the size of the entire planet. That's bigger than all of the continental United States, Mexico, Canada, and Greenland put together. To give you an idea of just how large this plate is, it's roughly the same size as the contiguous United States plus the states of Alaska and Hawaii. You can see how enormous it is when compared to other major land masses such as South America, Europe, Africa, and Asia. It also contains several smaller plates within it, including the Caribbean, the Gulf of Mexico, and the Scotia plates. But these are all technically part of the larger North American plate, which acts like a giant jigsaw piece floating on top of the planet's mantle. Now, the thing to remember here is that even though we call them plates, they are not rigid like ceramic plates. Instead, they're made up of smaller pieces of the Earth's crust and upper mantle that are constantly moving, albeit very slowly. They move at a rate of only a few centimeters per year, which is about as fast as your fingernails grow. However, these tiny movements can have a huge impact on the planet's surface over millions of years. The North American plate, however, is not the only plate out there. In fact, there are 7 major plates and several smaller ones that make up the Earth's lithosphere, the rocky outer layer of the planet. Each of these plates moves in a different direction and at different speeds, which creates a complex dance of shifting continents and colliding oceans. And it's this constant motion that has shaped the Earth's surface over time. The Himalayas, for example, were formed when the Indian plate collided with the Eurasian plate. And the Andes Mountains arose when the Nazca plate subducted, meaning one plate slid under the other beneath the South American plate. So it's clear that these plates have a major impact on the planet's geology and geography. But what makes the North American plate so special? Why is it the biggest of them all? Well, the answer lies in the plate's boundaries. A boundary is simply the edge of a plate. And the North American plate has 3 types of boundaries: divergent, convergent, and transform. At divergent boundaries, 2 plates move away from each other. At convergent boundaries, 2 plates collide with each other. And at transform boundaries, 2 plates slide past each other. The reason why the North American plate is the biggest is because it has more divergent boundaries than any other plate. Divergent boundaries are areas where magma from the mantle rises up and creates new crust. This process, known as seafloor spreading, causes the plates to move apart. And as they do, the North American plate grows larger and larger. This happens because the Earth's mantle is like a conveyor belt that moves magma from the core to the surface. And at divergent boundaries, that magma is free to spread out and cool, creating new oceanic crust. On the other hand, at convergent boundaries, one plate is often destroyed as it is forced under the other. This process, called subduction, causes the Earth's crust to be recycled back into the mantle. So at these boundaries, the North American plate doesn't grow. It actually shrinks. Transform boundaries are areas where the plates slide past each other and they don't create or destroy crust. Instead, they cause friction and stress to build up along the boundary. When the stress becomes too great, it is released in the form of an earthquake. And it's this continuous creation and destruction of crust at the plate boundaries that has resulted in the North American plate being the largest one on the planet. But now, you might be wondering, if the North American plate is always growing at divergent boundaries, why hasn't it crashed into other plates yet? Well, the answer to this question lies in the forces that drive the plate's motion. The Earth's mantle is like a giant pot of boiling water with currents that flow around the planet. These currents, called convection currents, are driven by heat from the Earth's core, and they move the plates along with them. At divergent boundaries, the convection currents pull the plates apart. And it's this pulling force that allows new magma to rise up and create new crust. However, the force of the convection currents is not constant. In some places, such as the Mid-Atlantic Ridge, the force is strong enough to overcome the gravitational force pulling the plates down. And this allows the North American plate to continue spreading. But in other places, such as the Eastern Pacific Ocean, the gravitational force is stronger than the force of the convection currents. And this causes the North American plate to sink down into the mantle. This sinking motion is what creates the deep ocean trenches that are found at convergent plate boundaries. Now we come to the question that we teased earlier. Why is the North American plate prone to sudden and violent movements? The answer is once again related to the plate's boundaries. As we mentioned earlier, at transform boundaries, stress builds up along the plate boundary until it is released in an earthquake. The San Andreas Fault line in California is a prime example of this. It is a transform boundary between the North American plate and the Pacific plate, and it is one of the most active fault lines in the world. In 1994, an earthquake struck the North American plate near Los Angeles, California. It was one of the most powerful earthquakes in the history of the United States, and it caused widespread damage to buildings, roads, and other infrastructure. In fact, the North American plate experiences more than 10,000 earthquakes every year. Most of them are small and go unnoticed, but occasionally a large one can cause significant damage. Another type of sudden and violent movement occurs at convergent boundaries where the North American plate is sinking into the mantle. As the plate dives into the mantle, it can get stuck, causing pressure to build up. When the pressure becomes too great, the rock can suddenly slip, releasing energy in the form of an earthquake. These earthquakes can cause volcanoes to erupt and tsunamis to form, as happened in Japan in 2011. The Tohoku earthquake and tsunami was a devastating natural disaster that occurred off the coast of Japan in March 2011. It was the result of an undersea megathrust earthquake that had a magnitude of 9.0 on the Richter scale. This made it the most powerful earthquake in the history of Japan and the fourth most powerful earthquake in the world since records began. The earthquake caused a massive tsunami that had waves as high as 40 meters, which devastated coastal communities along the northeast coast of Japan. The tsunami and earthquake led to the Fukushima Daiichi nuclear disaster, which is considered the worst nuclear accident since the Chernobyl disaster of 1986. In total, the disaster resulted in the deaths of over 15,000 people and caused billions of dollars worth of damage. To make matters worse, the North American plate is not done moving. In fact, it will continue to move for millions of years to come. Scientists predict that in the future, the North American plate will collide with the Eurasian plate, causing the Rocky Mountains to fold and the San Andreas Fault line to become a convergent boundary. When this happens, the western United States will likely be pushed up and to the north, while the eastern United States will remain relatively stable. It's important to note that these are just predictions based on the current state of the Earth's plates and their movement patterns. The actual outcome of such a collision could be different and may depend on factors that we don't currently know or can't predict. As we have seen, the Earth's plates are constantly on the move and they have a profound impact on our planet. The North American plate, the largest of them all, is a testament to the power of the Earth's internal forces. From the creation of new ocean floor at divergent boundaries to the recycling of old crust at convergent boundaries, this plate has been shaped by the relentless turning of the Earth's mantle. And while it may seem like the biggest plate is the most stable one, it is, in fact, prone to sudden and violent movements that remind us of the incredible power of the Earth. Perhaps the most important lesson we can take away from studying the North American plate is the interconnectedness of our planet. Everything is connected and everything is in constant motion, from the smallest atom to the largest continent. The Earth is a dynamic and ever-changing place, and we are just lucky enough to live on it. Well, that's it for today. I hope you enjoyed learning about Earth's biggest plate. If you did, please leave me a like and a comment below to let me know what you think. Also, if you haven't already subscribed to my channel, please do so that you don't miss out on any of my future videos. Thanks for watching, and I'll see you next time.